you already covered literature review, then you have a critical analysis or critical review, whatever you want to call it. Just mention that technical description in the beginning. So if you remember, if you go back to your coursework specification, I've mentioned a few headings there, and one of two key ones I wanna see it in the actual report is your technical description and your critical analysis, or critical review, I've called it, or analysis. Critical review. These are essential, guys. I've already put 50% here and 20% here. We have other related aspects. You can like show me that, say that these are your related aspects, like your appendices, some definitions, other things that's not majorly your thing that you actually reviewed during the actual report. So that will be your related aspects, which have another 20%, I think. Related aspects. Can be anything, guys. Can be some as well, some research, but not the main part. For example, if you've done security, so you might say that these are the other definitions within security, like security requirements. And you covered, like, for example, cryptography. So you say these are related, but not majorly the main part of the actual report. I want to see those, guys, because if I see the literature review, I wouldn't know exactly how to assess your literature. So if I see that part, for example, technical description, and inside it's set up 1.2, 1.3, 1.4, that's fine. But just give me that in the beginning as a heading, this one as a second heading, and that one is less important. So people ask me, how can I get the high marks? For example, if I just hitting the passing mark, if you said I've already have technical description, some sort of information that I reviewed, and then I have some sort of critical analysis, you should pass. Everyone should pass. For those who are hitting the high marks, you are going for technical description as your literature review, describing the topic you're trying to review, and then you should have like a storyline going towards your critical analysis. For example, you've looked into set of protocols or mechanisms. They are reviewed here, and then you give me your own point of view in the critical analysis on those things that you reviewed. I don't want to have a report that's in isolation. For example, I've covered wireless security in general. Then I went into details and I said, one of the most important things is cryptography. That's very general. Doesn't give you that high mark that you're looking for. So you need to be careful there. What are your goals? And therefore you'll be assessed based on that. If you have any further questions, I'm more than happy to answer it. If you want to show me your actual research report, I'm happy to see it. By all means, just either you come to my office or either you show it to me after the lectures or the tutorials. More than happy to have a look. I'm not going to read it. I'm just going to give you my point of view. Okay, that's it.
What's the final 10%?
This presentation, structure of it. For example, a lot of you, when you do the actual report, there's no structure. So you put them like this, headings. Just give me numbers, guys. Just don't let me find it out which is related to what. So I just want to see that structure. Referencing, that'll be one of those as well. Fit into your structure as well. Because some of you might go for 3 references. Some of you will go for 15. So it's unfair to say that those guys who went for more references should have more strength of the report in overall and in the structure-wise. So I'll look at that. So that's basically your 10% of the left. For those who are doing software, I've been asked a question, is it necessary to have it on a different machine? Yes, different machines is one of the essential components for you to pass your actual programming part. I don't want to have it on one machine, that's very basic. 2 separate machines, whatever programming language, whatever some of the things that you hit on us, i.e. your interface, your actual multiple upload and download, that's fine with me. But I want to have them on 2 separate machines. Your own laptops or the university labs, whatever lab you're going to do the Viva in. The port number, one of the students found out, which is, he said 1024, that's a port available that you can use to actually open your access to the ports, i.e. to make 2 machines communicate. That's basically what I want to just explain before I go to revision. Any questions before I go to first lecture of revision? So guys, my main goal of the revision, basically, I want you all to pass. For those attended lectures or actually done the tutorials, you should 100% pass. You should have no reason not to pass. For those who've done the work intensively, you should get a high mark. All I've said during all the lectures, and you'll see in the exam, whatever we did in the tutorials and the lecture should be in the exam. There might be tricky questions here and there, but that's just 10 to 20%. That's nothing compared to what you're looking at. For those who are looking for a pass, if you came in and slept during the lectures, you should pass as well. By all means. So what I'm saying is, the reason of today's revision basically is just to go on the things that I think they are important. I think they are important, not just some words I'm using here. But they are important, put it that way. And I said, one of the main things, two things. You have practical questions and you have theoretical ones. Don't skip the theoretical ones. They are very, very simple. Just read them, understand them, and just, if you memorize it, or just give me something. I don't want to have the word by word. I just want to have the idea. For example, I'll ask you, what is TCP? Just tell me. TCP is one of the protocols used in the fourth layer to deliver reliable services. That's one. Don't have full details. Just give me something. Don't leave it empty. Just don't leave things empty. Even if I want to help you and push you, I cannot give you marks on something empty. Just write something. Your name, that's fine. Just do something. Don't write your name, guys. I'm being recorded. Don't write your name. Whatsoever, don't write your name. That's a mistake. Don't write your name. I'm sorry. Just don't do that. I'll be in a big trouble. Yes. Don't leave things empty. What else?
You can write name of the technologies.
Sorry?
You can write name of the protocols.
Yeah, not just the name. Just write. Some people write the question again. Why do you do that? Just write something else. Just write a different question than inside. No? That's fine. External examiners will look at your papers. Even if I try to help people, you have internal moderation, and then there's an external examiner after me. Will check. So even if I want to help students, I cannot push them to as a limit. Last year I pushed, let's say 10 marks, and the passing mark rate was only 3 or 5 just did not pass for the first attempt, and I haven't seen them in my life since I was putting it out. So I'm not sure it used to be in our students, but that's not the key. What else? So that's the theoretical thing. Don't leave it. So for example, lecture number 1, it's very basic. Most of you might know the information. Don't skip it. Just read it. You might have the 25 marks very easily given to you in the exam. So don't skip anything. Just read it. If you want to just skim it, that's fine. You will remember stuff if you see the actual questions. That's the theoretical things. Practical stuff. I'm going to focus in the revision on all the practical stuff. Sliding window, CRC, your routing, Dijkstra algorithm, everything, subnetting. This will be your chance to revision stuff. If you did not understand it during this tutorial, or this lecture, there's no other chance to do it. So I would advise you all to actually just try to understand it. If not, I'll give you some chance to practice it during this revision and the tutorial as well. So it's like 3 times. No excuse, that's what I'm trying to do. Okay, so I'm starting with one of the most important parts during your lectures. I've said that 300 times already, sliding window protocol, reliable service. We are going to focus on go back N, which I'm going to explain what is that, your recovery strategy, and I'm going to focus on your full duplex, not the half one, the full duplex, i.e. both sides can send. If you look at the previous exam questions, mainly most of them are, maybe all of them are, full duplex, and there is some sort of an error happening. An error corruption of a packet not arriving to a destination. This is like the trend throughout all the exam questions. I doubt this year will be different. So I would focus on your previous exam question. Today, I'm going to do 2013 and 2011, sliding window protocols. During the tutorial, I'll find that maybe 2012, and ask you to practice it, and I'll do it afterwards. So that you covered 3 years already. Okay? If you manage to do that, I'll hang myself if you didn't pass. Let's put it that way. There's no reason you shouldn't pass. I cannot see that. Okay? So just do the work. That's what I'll ask you to do. You have enough time? So yeah, let's keep on. Let's speak on. Reliable services. So what's a sliding window protocol? Basically, we're trying to add sliding window protocol over something that's not reliable to achieve that reliability. So how can we do that? Sliding window protocol can be added on layer 2 and layer 4 protocols. But we are focusing only on layer 2, i.e. low backend. That's your error recovery strategy. So in packet switch networks, what is meant by reliable service? We mean by reliable service, if packets arriving in order, no missing packets, we should have receiving all the details arriving, and whatever you send is being received. That's very simple. They should be in order. That's the main key. They should be in order. And then you have them all arriving to a destination. So how is it implemented? We said we use sliding window protocol here. So for reliable transfer, the segments must be in order, no duplicates, no missing segments, no transmission errors. And if you see, as I already told you during the exam, I'll say there's a transfer error in the actual question. So we need to say, how do we rectify that? How can we go around it? When we have either a retransmission or a delay or something else, depending on the situation. Implemented by adding the sliding window protocol on top of the basic service provided by point-to-point protocol. One of the protocols used in layer 2 called point-to-point protocol, which is very simple delivery between two endpoints, source and destination. And if you see in your actual sliding window protocol, we have terminal A, terminal B, so two end terminals. We don't have multiple users, just two end terminals. Major variation of error recovery. We have go back N and selective repeat. We are going to focus in sliding window protocol only on go back N. What is go back N? Just a reminder, guys, go back N basically is basically, we do not accept any frame, any packets out of order. We don't store it, we don't keep it aside, we just negative acknowledge it because it is not in order. So, very simple reminder. That's your sliding window sections, bounded by time, whatever time that is. 0, 1, 2. Message is sent, arriving with the right destination, that's the first message. Second, did not arrive, number 2. So how do we track it? We track it with the variables, eventually I'll show you that. And 2 arriving, that's a flag. This is not in order. Whenever you do that checking part, whenever you find it's not in order, you need to negative acknowledge it. We will not accept that message. You only accept the message that arrived in order. So you say, I negative acknowledge this message, basically because I already received number 1, for example. Again, don't worry about the variables. We'll play with that in details, in more details. But that's go back in. Go back in. Just a fast reminder. That will be seen intensively during the actual questions. Just a fast reminder. That's your go back in. Selective repeat, which is the one where you store the details and you accept the messages. That's only layer 4. That's not part of your sliding window protocol because it becomes very complicated to actually understand or to do. So, sliding window protocol can be considered as a state machine. I.e., you have variables on both sides. You have a variable of the sender, variable of the receiver, and a variable of acknowledgements. That's basically the main things that I'm going to track. That's it. And they are bounded by the messages that are sent from the sender to the receiver. One small thing, and I was speaking with one of the students and he said, I'm not going to design a protocol. You've already told me there are 6 questions and 4 to answer. Fair enough, if that's the case, that's by all means. But I think sliding window protocol is one of the easiest way of getting this 20 marks, basically. So if you don't hit the full, but you cannot be very low in a sense, because the first 10 messages are very basic. Messages sent, you track it. It might be a little bit complicated if you send acknowledgements or there are messages going to time out. So it might be that the case, but the first 5 messages, if you just done the basics, that's 10 marks up to 12 for your pocket. That's the other parts will accumulate eventually. So I would seriously consider signing the protocol. That's my opinion. But it's entirely your call. I've already told you from the beginning, 6, and that's 4 only. That's it. There are variables which change when events take place. So essentially, we have 3 types of variables. We have variable of acknowledgement, variable of sender, of receiver, let's put it that way, and variable of the sender. They change whenever you send a message. So if I'm sending a message, logically, what do I change? I change my variable of sending. So they increment one by one. They have a normal incrementation. So if I'm sending the first message, 0, they all start from 0. So if I send this, I'm sending, the variable will move to 1 increment. If I'm receiving, on the other hand, if I receive, and basically when I receive a message, I will update my receiving variable, goes to 1, and I update my actual acknowledgement whenever the value is being given. They don't increment normally, they depend on what the value inside those messages. People might say, where do I find those variables? It depends on when we have your numbers, your actual, we'll give you the numbers that start from 0 up to 3, and then they revolve after that, your bit number. So that's basically the numbers I'm going to use in the messages. So the variables all start from 0. They change depending on who is sending, who's receiving. If I send a message, I update my variable of sender. If I receive the message, I update my receiver variable and my acknowledgement. These are the variables that change and updated depending on those messages. So there are variables which change when events take place. So when the events are, the messages have been sent. And I always give you the messages in the exam questions, or in any question, I'll give you the messages that are sent between A to B or B to A, depending on the messages, which direction they are going. The flow of the actual messages, these are your events. So I'll say messages are sent at millisecond 0, 1, 6, 7, whatever the message is. So these are your events. And whenever those events are being sent, they change depending on the situation. It's essential to be able to uniquely identify each segment to verify whether the first 3 requirements are satisfied. How can we do that? We'll do that using what we call sequence numbers. So the sequence number are your keys. The key of the actual question is your sequence number. What are my sequence number? Usually the sequence number will be bounded by the n bits. So I'll say usually you'll have an n equal to 2, which are, and then you find the formula of finding your sequence number, which basically is, so the sequence will be basically your 2 to the power of n minus 1. And that's 2 to the power of 2 minus 1, and that's 4 minus 1, and that's 3. So that means your actual sequence number should go from 0 to 3. I'm not sure in the question I've sent, either I give you n, or I gave you your sequence number are 0, 1, 2, 3. With the, if you remember in the transport layer, we had more than that, but with your layer 2, starting with the protocol, I'm only sticking with these sequence numbers. So you only go from 0, 1, 2, 3, and then you go back to as the same order. Don't go to 4. There's no 4 in here. 0, 1, 2, 3, and you revolve backwards to as a 0. That's basically how it works. That's your sequence numbers. Where are they mentioned? They are mentioned on your event, on your message. Usually I say an iframe, for example, S equals, that's your sequence number. That S is referring to your sequence number. Okay? They start from 0 to S3 and they revolve back. So the first message should be 0. The first message should be 0. Okay? How many sequence numbers I've already mentioned, we're sticking from 0 to 3. How will you decide how many you need? If you have an actual formula, you actually say 2 to the power of n minus 1. I will give you how many you need. What restricts the number? The n bits that I gave you in the example in the question order class. So n will be a restriction. If I say n is 3, then just go higher. But stick with 2. You're only sticking with 0 to 3. This is our, just, whenever we see this, the first time we will see that, what are these events? So basically these events is mentioned, for example, if I would translate this figure into a question, I'll say your messages are sent from A to B in millisecond. If I follow that, that's 2 millisecond, 5th millisecond, and then the 8th millisecond, and there's in the 13 and 15 as well. So basically these events are mentioned in the question, messages sent from A to B. If there are messages going back from B to A, they will be mentioned like this, B to A. Very simple. These messages are known as iframes. Iframes are your data. So if I'm sending an email, that's basically is an iframe. We'll have a sequence number inside that. So basically an iframe is the ones that we need to track. And these are the only messages I'll give you in the exam question. I'll say your iMessages or your messages being sent are these. Or these are the ones that has sequence number inside. These are the only ones that have sequence number inside. Your acknowledgement, your negative acknowledgement will not have sequence numbers. Okay? Let's try to do this one. Very simple. And then I'll jump to a more complicated question because I'm not going to go into full details of those. So let's start with the first one. And how can we actually update our variables? I'm going to do the half duplex part just to remind you of how do you update your variables. And then we'll do a full duplex and remind you how to do the variables, and then I'll do an actual question. The key is your variables. You'll be marked on your variables, on your messages, the events being sent, and the actual information that are bound clients. So the information on the event, you'll be marked on that as well. So let's see how does that be discussed now. It's easier to start from 0 because in the exam I'll give you messages by the millisecond. And I usually look at them starting from 0 up to an infinite number of milliseconds. So now it's 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's stop at 10. No space. Just, guys, the numbers I'm mentioning here, 0, is for both sides. So if I would actually draw it in the right way and make things more clear, I would say the other side should be the same time, because this is your time. This is basically your time, and they are the same on the both sides. So I would do the time as it is. I would just follow the same direction. So I would know when I send a message when it's going to arrive to its destination. And usually in the question, I'll say a message will require X amount of milliseconds to arrive to a destination. In this, how many milliseconds the message is required to arrive to the destination is 1 millisecond. Message is sent at the 2 milliseconds, arriving at the 3rd. That's basically how it's being sent and when it will receive. It's better to put it in the same part because then you can track it properly. And then you update the variables properly. That's one of the trivial things, but they are important. So what are the variables that we have? I'm doing now half duplex. So I'll just have one side sending, one side is receiving. Usually I'll have a variable of acknowledgement, variable of sender, and a variable of receiver if I'm receiving any messages. But in this case, I'm only doing a half duplex, so I only have one side is sending and the other is receiving. But we are focusing on full duplex eventually. Just let's break this one to a simple one first and then see how this will work out. They all start with 0. So that's your starting point. If I look at the figure at the moment, there is a message sent at the 2nd millisecond. As I said, you will be given the messages, for example, A to B, and these are 2, 4, 5, 6, whatever the messages. So I'm going to follow that. So see, the first message is sent. The first one is sent at the 2nd millisecond. Second, it will arrive at the 3rd because it requires 1 millisecond to arrive to the destination. These are, again, your iframes, your data. And iframe basically would be, you need to mention the sequence number. Where do you start in your sequence number? You start from 0. So starting from 0. What do? You update the sender and the receiver. So whenever I send it in the 2nd millisecond. So I update my variables in that 2nd millisecond. The first thing I will do, I increment my sender. So the variable of the sender will go up to 1. In the other side, I need to update my variable of receiver. I've already gave you a formula. I remember when I explained that, citing with the protocol, saying that if the variable of the sender equals the variable of the receiver, then everything is working normally. So you increment the both sides. So if I'm saying now at the moment, the variable of the sender, which is 0, equals the variable of the receiver, it is equal, 0 equals 0, and then you update both sides. I've updated my sender, and now I'm going to update my receiver. At this stage, any questions? Okay, second message. By the way, I haven't defined 2 main variables, your timer or your window size. I'll leave that next slide. We're just doing the basics, the very basic stuff. A message is sent at the 5th millisecond. That's your 5th. That's how the message sent now. 5 arriving at the 6th. So what is the information? It's an iframe. S equals, you increment that. It goes from 0 to 1. Or you want to say I don't want to memorize that. I want to copy whatever I have as a sender. That's fine. Put it inside. A variable of the sender is 1. At the moment, is the variable of the sender equal the variable of the receiver? If I update that, yes, at the moment they are 1. So yes, I can increment normally. 1, whenever I send that, sender will go to 2. Whenever I receive it, receiver will go to 2. The trick is, whenever you receive, you increment. Whenever you send, you increment. So I've incremented my sender at the actual 5th millisecond, whenever I send it. And I'm updating it in the 6th millisecond in the receiver side, because this is where I received it. Okay? That'll be something important to notice, because things might change whenever you try to send the same messages at the same millisecond. There is other message going back from the 9th millisecond to the 10th. Let's make it very simple here. Let's make this one arriving from the 7th, arriving in the 8th. And in here, I'm acknowledging, receiving my messages. So what do you acknowledge? What is your acknowledgement? Why is it 2? Because you received 2. For simplicity, just copy. Whenever you're sending, just go back to your receiver and say, what are the last number that is there? And basically, that's 2. Copy that inside your acknowledgement. Therefore, that's 2. What happened to the other side? He updates whenever we receive that in the 8th millisecond. This goes to, the acknowledgement goes to 2. That's it. These are the 3 main messages on the thing. There are 2 main messages, but the 3 main variables that are changing. That's it. This is the basic of sliding window protocol. Before I continue, any questions? If I would continue, okay, now things will become more complicated because I need to define 2 more variables or 2 more essential parts. One of them is called your timer, and the other is called your window size. Okay, timer is being defined as a limit number to know exactly when will the actual question time out. I'm not going to go into details why do we need it and how is it important in the other slides. I'm just going to break it as simple as I can in here. Timer. For example, if I say timer is a 5 millisecond, that means whenever you send a message, if I did not receive an acknowledgement by 5 milliseconds, and then you don't count whenever you send, you count after. 1, 2, 3, 4. Therefore, the 5th millisecond will be in here the 7th millisecond. So what I'm saying is, if I did not receive an acknowledgement by that time, it will time out. What happens if you time out? This will be resent again. That's it. How do I count? Just don't count the 2. Don't say 1, 2, 3, 4, 5, and you say the 6. Just 1, 2, 3, 4, 5. That's in here, will time out. If I did not receive a message in the question saying that the message is going from X, from B to A, by that time, by default, you want to send an acknowledgement. By default, you want to send that acknowledgement back before it times out. And that should be before it times out. So it's in the same millisecond. It times out at 7. A message can come from 6 to 7, acknowledging whatever you have there. That's the timer. Questions on the timer? Okay, let's now ask the window size. So what is the window size? The window size is there to limit the number of messages being sent from one side to the other. To limit the number of messages are sent from one side to the other. A to B or B to A. Why would I need that? You need to control things. You need to actually control the number of messages. You need to control the window size and the actual operation. You don't want to have a million of messages going and then you lose track. You need to receive the acknowledgement. So there is an actual window size to enable us to track things. I'm not going to go into details again why, what are the issues. I'm just going to show you as simple as I can. So let's say, for example, the window size in here is 3. What does that mean? That means that one side, for example, A, in this case is only A because it's a half duplex, can only send 3 messages. Can only send 3 messages. So when will he be able to receive to send the 4th or the 5th? he will be able to receive that, to send another message whenever you start receiving acknowledgements. So imagine it as this way. Imagine you have a buffer on the side. Put it that way. You have a container of messages. And these will be filled out by message whenever you send. So let's say I've sent the first message in the second millisecond. And you say, I've already occupied this space. I'm now allowed to send only 2 messages. Then I send another message. And therefore, it goes to your window size from 3 to 2. To 1, sorry. So you already sent 2. And now you have only 1 message to send. If you send that third message from A to B, the window size will be 4. So you might ask me, are you telling me that if I have in the question, messages should go out there first, second, third, and fourth millisecond, but my window size is full, I cannot send number 4? Yes, you can't. Question will come back, where can I send number 4? Whenever I receive acknowledgement, either one of those. Because if I receive an acknowledgement for the first one, for example, let's say acknowledgement arrives saying I've received 1. That means that space is now empty for you to use again. This is how simple it is. If the acknowledgement came in saying that 3 instead of 1, what does that mean? The 3 messages you send is now acknowledged. Now you're allowed to send another 3. Is that clear? These are the key. If you understand those 2 things, that's it. Done. Questions, guys? Don't hesitate. Ask me questions. This is the last time we're doing this. That happens, sorry about it. But ask me questions now, because you're going to practice it. This is a good way of practicing stuff. Right? Move on? Oh, sorry. Okay, so I'm skipping those because they are to break down stuff and why the timer are useful and why the actual window size is useful. But we don't want to know that. We don't want to know it, but at the moment we want to do the questions to understand how can you do things. So I'm going to jump into a question. In the first tutorial that we had, if I'm not mistaken, yeah. Oh, come on. Yeah. We're going to do question number 4, which is in a half duplex one. Okay? Still have enough time. So we're going to do the half duplex one to make things simple. To break down again the variables, the messages, now we have the window size, and we have a timer. So we're going to go into details. I'll do that, and I'll do a full duplex afterwards, and then we'll have a break, and then I'll give you some exam questions. You do one, try to practice it together, and then I'll do it afterwards on the board. I have 2 exam questions today. So I think we have enough time to do it, so let's try to go on. So before I read the details of the question, basically I'm giving you messages. So if I say, first of all, assume 2 network devices, A and B are connected each other, and the sliding window protocol is in operation. And layer 2, which is basically the go back end, a simple one. I'm basically giving you the messages sent from one layer, i.e. to the other, i.e. from A to B, that's the main thing. So these are your messages. In other words, these are your events. These are your iframes that you need to track. And these are the only messages you need to track. Okay? I've sent the messages at 1, 5, 7, 8, 9, 10, 17. From A to B. It's a half duplex, so all on one side is sending to the other. Note this is a half duplex, okay? Note also that there are 4 sequence numbers. In other words, you have 0, 1, 2, 3. So these are your sequence numbers inside your events. What happened after 3?
Go back to 0.
You go back to 0. That's the key. Don't go to 4. And the window size is 3. The first information that you got from the question is your messages. You write down the messages, and then you have the window size. And at the moment, the window size is 3. Write this down on the side, so you keep track. You don't forget those. It takes 1 millisecond for a frame to be sent across the link. So what I'm saying is, if I send a message from the second, it will require 1 millisecond to arrive, and that's 3. If I send it at 4, it requires 1 millisecond to arrive, that's 5. Basic information. Okay? This might change. I'm sticking with 1. Okay? The receiver must reply within 4 milliseconds. So what does that mean? Your actual timer is not 500. Your timer is 4 milliseconds. These are the things that you want to get from the question. Okay, let's start with the question. Again, it's a half duplex, simple, but it's breaking down the stuff for those who do not understand it for the first time. So in this question, I have a half duplex, A sending to B. I'm putting this side as A, and I'm putting this side as B. You can do it any way you want. We have 3 main variables at the moment because this is a sender sending to a receiver. In this side, you'll have 2 variables. You have a variable of acknowledgement, and you have the variable of sending, because this side is sending. On the other side, you have a variable of the receiver only because this side is receiving. That's basically what it is. They all variables start with 0. Your timers in here start from 0. Let's follow the messages. So the first message is sent in the question is from A to B, 0. That's the first message. How long it will take to arrive to the destination? 1 millisecond. And that's 1 millisecond arriving to the destination. First thing, this is a message that I gave you in the question. So basically, this is a datum. This is iframe. We start with your sequence number, and the first number to start with in your sequence numbers is 0. What do we do for second? We update our variables. Whenever I send a message, I update my details. Whenever I receive it, I update it. So if I send at the 0 millisecond, so I track it, 0 millisecond, my variable of the sender goes to 1. I've received it at the first millisecond. My receiver at the 1 millisecond goes to 1. That's it. If I stop here, I say I mark it. 1, 2, 3, 4, 4 blocks. Again, it's a full duplex would be the 2 things that need to work together. So this is how simple it works. I'm not going to look at the final answer. Okay, did he manage to find the actual error, the delay, and stuff? These will be marked alone. So for example, acknowledgements, sending back might have 2, 3 extra marks on it. Delay will have 1 or 2 marks extra. And actual negative acknowledgement will have like 4 marks. But the rest should give you at least 15 marks. Because you will be marked on the variable updates, the message events inside it for both sides, that's at least 15. The other rest are 10. We have another message sent. We track the time. Message is sent at the first millisecond arriving from A to B. And basically that is 1 arriving at the second. Same thing, iframe, because I've mentioned it in the question. S now is what? You can either take that one, or you say it's normal increment, 0, 1, 2, 3, 0, 1, 2, 3, very simple. That's 1. People must say, okay, wait a minute, I want to make sure this is in order. The formula that we have is the variable of the sender equal the variable of the receiver, then you increment both the variable of the sender and the receiver. In this case, is 1 variable receiver at the moment, is it equal to the sender? Sender and receiver. Yes, 1 is equal to 1. So everything's normal. There's no out of sequence. This formula will be very useful when I have a message error, which is sent but not received. Where you update the sender but you couldn't update the receiver because it's not received. That would be an issue. So what do I do first? I update my sender. When did I send it? At the first millisecond. 1 goes to 2. When did I receive it? At the second millisecond. 1 goes to 2. Another message sent in the 5th millisecond. Now, I want your help. 7, 8. So what are the 2 things that I defined in the beginning? I said my window size is 3. My timer is 4. Is that right? What does the window size mean? It means that I cannot send X amount of messages unless I receive an acknowledgement. If I have that in the side, if you want to keep that on the side and say my window size It's 3. I've already sent 1, and I've already sent 2. Is my window size full?
No.
So you are fine to send the third message, which is in the 5th millisecond. Oh, wait a second. Can I send that? So the question says, you need to send the 5th, arriving at the 6th. Can I send this? Why?
Haven't had an acknowledgement, so it's longer than the timer.
So if I do that counting, the first message sent is at the 0 millisecond. So let's count together. 1, 2, 3. So in other words, this message, the first one, will time out in here if I do not receive an acknowledgement, which is happening. If I continue with my question, I can send it, but this will time out. This will not be acceptable. This will never happen unless I tell you it will happen in the question. Okay, and I say there's an issue here. So by the normal flow, you should do what? Receive the acknowledgement. It's not mentioned in the actual question. You just say a message go back from 3rd arriving at the 5th. 3rd arriving at the 4th. That's not an iframe. It's not mentioned in the actual question. So this is what we call a supervisory frame. This will be basically just an acknowledgement. Either you call it A, put acknowledgement, that's fine. What do you acknowledge?
2.
You acknowledge 2, the messages that you received, which is where is it? Basically here it is. I've copied it inside 2. Whenever I receive that, I need to update my details. So what do I do from the other side, from A?
Add 2 on the variable.
I update my actual acknowledgement 2. What happened to this window size? So now 1 and 2 received. They go back to 3. Is that clear? Now I need questions. Questions. So that means everyone understands that. Yes, please.
This is a half duplex, yes?
It is a half duplex, yes.
How can the program from B to A?
Yes. This is not an iframe. When you say a half duplex, that means only one side can send data. And the data are your iframes. In this case, this is a supervisory frame. It's not counted as a data.
Do we do this in exam as well?
Yeah, of course. Yeah, you need to receive, you need to send me that, of course. But it depends. Your question, as I said, I'm focusing on full duplex. So even if that question have a case, that message is going in both ways, but one of them will time out, you send an acknowledgement back. That's one of the main things. Yes. Guys, what do you think? Questions? If you understand that until now, that's the basic stuff. The full duplex will be more complicated, but let's just continue a little bit and then we'll see. But so I have a case where a window size might be full. So let's say a message now is sent at the 5th millisecond. Everything now is reset to normal. Your window size is back empty, and these are not, you'll not count the timer in here anymore because they've already received. They will not time out. Whatever acknowledgement means, they've reset everything to 0. Your timer is back normal. Your messages of the window size is times. You can send whatever you want. So a message is sent at the 5th millisecond. Continue with the information. Everything continue now. Don't reset the information of the events. You reset the timer and you reset the window size. But the event, the information stays the same. They'll go back to 0 unless they finish. So this is again iframe mentioned in the example in the question. 5th millisecond. So S equals what? Why is it 3?
The seconds number don't change.
No, they change. But 0,
you don't
1. Why is it 3? 2 is acknowledgement. It's not a sequence number.
Oh, 2. Sorry.
So yeah, it's very easy to make a mistake. Unfortunately, with this funny thing, it's just basically very easy to do it. But that's basically another message sent from this side to the other. There's no changes in your iMessages. I'm tracking those. Just let me circle them. So basically, if I say what is the message here, it should be 2, 0, 1, 2, basics. This is 2 for the acknowledgement. That's it. So now let's continue the message with the variables. If I want to say is a variable, if I send this and I said I'm sending now from this side, So now, what is the information that I'm going to update? I'm just going to update my sender. So 2 goes to what? I've received it in the 6 milliseconds. So the receiver will be what? Basic stuff. Continue with it. Normally, nothing had changed. Okay? Now the window size, go track it back. You've already sent a message, which is that one. One has been sent. So now you're allowed to send only 2 messages. You have a message sent at the 6, 7, 8. So now let's go with the 6. 6 arriving at the 7. iframe. S equals what?
3.9.
Yep, 3. Let's update the variables. 3 goes to where? 0. Go for it. You update your receiver. 0. Another message is sent. Now let's go back to window size. Let me track things. Another one is here. Can I send another message?
Yes.
Window size is not full. 6 going to the 7. Sorry, 7 going to the 8. Sorry. So that's an iframe. S equals what now? 0. Update information. 0 goes to 1. Receiver goes to 1. I have another message now sent from the 8 going to the 9. Can I send that?
No.
By the way, I'm tracking things here. Can I send that? Why?
Because the size is full.
Because the window size is full. What happened to this message? How do you rectify that stuff?
Have to send an acknowledgement.
When do you send that acknowledgement? That's a key. People must say, what? Before it times out. Keep that in mind. Whenever you send that message now, this is the first message. Everything now is resetted. So don't look at those 2. That message is now started to count. 1, 2, 3. This will time out at the 9th millisecond. At the moment, there's no issues. But the window size now is full. How can I rectify stuff? This will be saying that a message should arrive back from the 8 towards the 9. And that should be only an acknowledgement. What acknowledging what? What's the value?
1.
1. You just copy. What happened to this message? We already said there's a message sent at the 8. What happened to this?
Delay.
Delayed until when?
When the
Whenever you receive that acknowledgement. So now the 8 is delayed. And now 8 is sent from 9 to 10. And the others are delayed. Wherever are the messages, for example, in here, I know it's very, sorry, let's do it that way. So 8 and 9 is delayed. 8 is delayed to 9. 9 is delayed to 10. So that created some issues to the other messages. That's fine. But just track them. And you say delayed, and that's it. So now those 2 came together. The window size and the timer. This is the only trick. If you understand that part, there's no way you'll mess things up in the exam. Did you understand that part? That's not the question. Questions? Come on.
I thought you were supposed to send a frame from 8 minutes to 9.
What happened to that?
What's the latest one?
What?
Because of the timer?
Because of the no that
The window size.
because of the window size. When is it being sent now? Whenever the timer allows you to send that, that's acknowledgement coming back,
Yeah.
which allow you to send the messages. So 8 is delayed to 9, 9 is delayed to 10. Okay?
Still sends out.
So you continue sending normally. Don't stop sending. You send normally. You follow, but you say it's being delayed or not. That's it.
So you're sending the 8 millisecond at 9.
Yes. That's why I mentioned the word delayed.
Do
Delay
write,
sending it.
do it right delay in the exam?
Yeah, right delay.
Or
Just write delay. What will it affect you? Because, for example, that delay will have more 3 marks on it or 2 marks on it. Okay? So these keywords will help give you marks. If I see you actually delayed it, but you forgot to put the word delay, that's fine. It's still you get the marks because you did the actual operation, the actual function. That's the main reason of it. Questions? Okay, so shall I do a full duplex? and ask you to practice thing, or practice and then full duplex?
Now, can we do the last 20 because it's 17, isn't it?
17 one. You want to do the 17,
Yeah.
you mean? Basically, what will happen here? Similar to what happened here.
Exactly. Which one? Sorry.
This is the first part.
The time actually.
Because you will be able to set, because now everything is being reset. Your actual window size will be empty. So you start sending a 9, the 8 into 9, 9 into 10, and 10 into 11. When are you going to, will you wait to 17 to send? No, you need to receive an acknowledgement because of the time. And the 17th, you send it. So let's say now you have only 17 left.
Yeah.
What do you do? So let's say you only have now 17 in here. So how can I finish the question? So if I say I only have 17 in here, that's basically what it is. So I send 17. I'm not going to write the details because I'm not sure what the details are. So 17 basically will say, now there's no messages, it's stopped. So how do you finish it? You count 18, 19, 20, 21, and by 21, you need to receive an acknowledgement. That's it. Okay, so do you want me to do a full duplex?
Yes.
Okay, I'm going to do the full duplex part in the question number 5. And then I'll give you exam question 2013 or 2011 to practice, and I'll do it afterwards. Yes?
Just go back to this.
Yes.
Would that acknowledgement at the bottom?
Sorry.
Do you want the acknowledgement at the bottom?
Yes.
Would that be equal to 2 as well again?
Repeat, sorry.
No,
The acknowledgement sent back.
yeah,
Yes.
the bottom.
Yeah.
Last one.
Yes.
Be equal to 2 as well.
It equals whatever the number inside the actual receive. I haven't charted it yet, so I don't know exactly what it is. Yes. No, people might say, why do I delay this to 8 to 9? Because the acknowledgement by then, whenever you receive it, you send it. That makes sense in whether I understand the question or not. You can't, because it's the timer. No, because the window size. Because the window size couldn't send it, because the window size is saying 3. So in that scenario was, if you go back to the question, 5, 6, 7, 8. 5, 6, 7, and 8. 8 I couldn't send because I have 5, 6, and 7. So that's the window size 3. So that's why I delayed 8 until I received that acknowledgement. If the window size permits you to send it, by all means send it. The delay happens because of the actual window size full, and the delay happens because the timer cannot allow you. So my question says, why did I receive an acknowledgement earlier? That's how the window size operates. It waits until the final millisecond before it times out to send it again. That's the only thing. So it's how it operates. Yeah, that's the question. It's just about how to track it. That's the only issue. Okay, let's do a full duplex and have a break afterwards, okay? So just, guys, have a 5 minutes break. Have 5 minutes break so you become refreshed. Because the full duplex would be something complex, okay? So it's 5 minutes only. You need to have enough time to do the rest, okay? 5 minutes. I'll start at 3:01.